Okay, so here's the problem. We want to print out the numbers from 5 down to 1. And so we need a strategy to do this recursively. And so using recursion, we're going to print the 5, and then we're going to print the rest of the numbers with another recursive call. So it's kind of like we're procrastinating. Okay, so print the 5, and then we'll print these other numbers later. Now, if we want to print these other numbers, we're going to print the 4, and then we're going to print 3, 2, 1 in a recursive call. So we're kind of putting this off and procrastinating it. And so we've broken the problem into two problems. Print one number and then print the rest. So to print 3, 2, 1, we're going to print 3, and then we're going to print 2, 1 in a recursive call. And once again, we've divided the problem into two pieces. So we want to print a list from 2 and 1. We print the 2, and then we print the 1 with a recursive call. And we're finished when we only have to print out the 1 with the last recursive call, and then we're done. So let's use stepwise refinement to nail this down and make generalized code that will work with any positive integer. So if we had a 10, it would count down from 10 to 1. So our problem is to print 5, 4, 3, 2, 1. In order to print 5, 4, 3, 2, 1, we're going to print 5. And we're going to print the rest of them recursively. If we want to print the 4, 4, 3, 2, 1 list, we're going to print the 4, and then we're going to print the rest recursively. So we have sort of a pattern here. So we can print n, and then we've got a recursive call with n minus 1 to do the rest of the list. So let's give a name to our recursive method. We'll call it countdown. So we're printing the first number, and then we print the rest of the numbers. Now, this is not going to be quite good enough because we need to stop once we get to 1. We don't want to go to 0, -1, -2, -3. So we need a little bit of a guard to stop. So if n is greater than 0, then we'll print it out and make the recursive call. We don't want to make a recursive call when n is equal to 0, because then this would be -1. So at this point, we can write out the method signature a little bit more explicitly. Still just using pseudocode. And at this point, we could test the program and implement it in Java, because it's close enough to Java code at this point. So at this point, we have a Java implementation. Let's take a look at how the recursive calls produce the result we're looking for. So we've got a diagram down here showing what's going to happen when we call countdown R4. So calling countdown R4 is going to invoke the print. It's going to put out a 4 on the screen, and it's going to call countdown 3. So we print out 4 and then print out the rest of the list. Okay, so the rest of the list is 3, which calls countdown R2, which prints 2, which calls countdown R1, which prints 1. When countdown R0 is called, nothing happens, it returns, and we've printed the integers from 4 down to 1. If we want to count up to 1, we make a very minor change in the code. We're simply switching the order of these two lines. So instead of printing n and then the rest of the numbers, we're printing the rest of the numbers and then n. So we want to print up to 5, 1, 2, 3, 4, 5. We print up to 4, and then we print 5. And that's basically what this is saying. So to understand that a little bit better, we have this diagram. When we call count up R4, that immediately calls count up R3. You can see because it's the first line being invoked here before print. Immediately calls 2, which calls 1, which calls 0. 0 simply returns, and then the 1 is printed. And then once this invocation returns, the 2 is printed. Once this invocation returns, this is printed. Once this invocation returns, this is printed. So we get 1, 2, 3, 4 being printed on the screen.